Welcome to my channel. I'm Zhan Xu. Let's look at the problem 67 in chapter 19. Chapter 19 is about heat, the first law of thermodynamics. You can see we have a cylindrical pipe. Look like this one. The inner radius, outer radius is given R1 and R2, right? I'll tell you the inner of this pipe has a hot water. The temperature T1 is given. The outside temperature T2 is given. You can see T1 is larger than T2. First one, we need to show the rate of heat loss for the length L of pipe is in this equation. And then tell you K is a constant. So how can we do that? We can see first word, the rate of the heat loss. This word is very familiar. It is just tell us the conduction function, right? We can see the conduction function tell us how the rate of the heat loss. The rate of heat loss equal to Ka delta T divided by L. Agree? This is we learned in textbook. Then we can keep going. You can see in this case, because the thickness for this pipe is high, so we need to consider the temperature at this point is different with the temperature at this point. Agree? Yes. So this temperature changes with radius. Agree? Yes. So we can write it as this way. We can see this is the L is a thickness, right, for this transferred regions. And this time we consider this L as delta R as dr. So the small fraction for this radius. So this is a dr. And then how much temperature it changed? dt. Agree? Because in this case we consider the temperature is different inside this cover. Agree? Yes. So we get the function. Where does this negative side come from? It tells us the energy is lost. It is travels from the inside to outside, so add the negative side there. Okay. Next one, how can you decide the surface for this cylindrical pipe? You can use 2 pi r times L because the length is L. Agree? So in this case, you input A inside, you get a function look like this one. Right? You can see we need to find dq over dt equals to this function. It looks like we need to simplify it. Right? How can we do that? Looks like we must do the integral with the dr and the dt. So we just convert the equation look like this one. So make dr to the left-hand side, r at the left-hand side, the rest part keep it at the right-hand side. It looks like this one. And do integral at both sides. At the left-hand side, integral r1 to r2, at right-hand side, integral t1 to t2. Do this calculation. You get the answer look like this one, and then can be simplified as this one. This is the equation we need to prove. Then we are done. The second part tell you some quantities. It tells you the pipes R1, R2, and T2 as numbers, and also T1 is given. Ask you what will be the initial rate of change of temperatures. Question. What's that mean? It asks you about the delta T. This is the temperature change, right? The rate of temperature change. So that means delta T divided by the time taken. So how can you connect it? Remember, we just did the conduction function. We find the delta Q over delta T. We see this is a rate of energy loss. Can you connect it with a rate of change of temperature? Yes, because we know this function, right? We know delta Q equal to Cm delta T. So at both sides, we can divide by delta T. Agree? Yes. So if we divide by delta T, you can see this part becomes this one, the rate of heat loss. And this side is what we are interested. This is our target. This is our target, delta T over delta T. The delta temperature over delta time. Now you can see we can input to replace the delta Q, delta T with this function. We just get at 0. Agree? Yes. So in this case, we can write the target delta T over delta T, this part equal to this function. No problems. Agree? Now you can see you input all the given quantities, get answer there. The next one tell you, suppose the water is 31 enters the pipe and moves speed at 8 centimeters per second. What will temperature drop per centimeter of travel? So this is easy because we just defined the initial rate of change of the temperature. See, it tells us for 1 second, the temperature will drop 4.8 centigrade. Do you agree? So that means in 1 second, but it also have traveled 8 centimeters. This is the speed for this water traveled. And the energy, you can see the temperature drops 4.835 centigrade. And then how long it traveled? 8 centimeters. So then you can get the answer. For 1 centimeter, the temperature drop is 0.6 centigrade. Thank you.